Nag-start na siya. So, kung gagawin ko naman tapos na siya. Pinakadala, 62.
Hanap ka na ni Ron na ni-serve na dokumento. Nakausap ko rin ito. Magbibigay siya sa akin ng ni-serve na meron. Sa akin na yung mag-serve.
Oh.
Hindi ba dapat yung student o
Yan. Meron ka bang backup? Meron backup daw siya ng student. Basta kami nag-log substation. Meron ka siyang hindi ako lang ginawa lang ng backup. PPT ka. Yan. Ano ba nang yan? Oo, pala.
Wait ka, may naka-charge mo mag-video sa akin. Paano na? Kailangan mo ba?
Gusto mo ng video?
Hindi, kasi may kamot mo.
Ito.
Hindi, kailangan mo ba? Ano, kasi mo na rin.
Hindi sa iba. Ito lang video streaming.
Video streaming. Ay, parang sino mo na?
Excuse me. Nag-record ko ba?
Live stream.
Pero hindi nire-record sa akin.
Nire-record din po.
Nag-save siya doon sa
Sa save.
Gusto po yan. Wala ka pala ka na siya.
Discussion for the social media.
Kasi there's
Dadalhin niyo ba yung mga DS? Iwan ka lang, hindi ko pa rin depende yung compact. Pero iwan. Introduction. Pero yung mga kapal yung
Sino nag-ano? Yung nabaon na ka.
Good morning. I am Buntag. Welcome to the Student Research Competition at the PNHRS. I'm Robert, and I'm your session chair, and with me is Kristine. Chris. Also, I'd like to introduce our moderator, Christian, and our documenters, Ms. Bulao, Ms. Baco, and Dr. Mulyaneda. Can you please raise your hands? Thank you. Again, welcome to our student research competition. And house rule first. May we remind the participants, including myself, to turn off your cell phone into silent mode, to put your cell phones into silent mode. Also, we would like to remind everyone that we are live at PNHRS 2014.healthresearch.ph, and we would like to encourage participants to post via social media using the official event hashtags #HealthResearchPH, #SafePH, #PNHRSPH, and #PLDT Home Fiber. Also, you can follow us on twitter.com/PNHRSPH, facebook.com/PNHRSPH, and for our, you have the following addresses. You're given, each one of you has this paper, so be guided. The passwords, you have PNHRS week, that's all in small letters. And then you have all caps PLDT 1234, all caps PLDT 5678, and so on. For this year's PNHRS Week celebration, our theme is Research and Innovation in Health for Disaster and Emergency Health Management. And so our objectives for this session includes that we learn from each other and that we learn to share information and experiences that will contribute to solutions to health-related problems. To kick off our student research competition, it is our honor to hear the opening remarks to be given to us by Dr. Debbie Abdul of Cebu Doctors University.
Can you see me? Mayong buntag kaninyong tanan. Magandang umaga po. Good morning to everyone. This is a welcome to the 8th PNHRS Week Student Research Competition. This morning's session will have 6 papers to be presented by the students who represent their institution. For the session, we were given 3 hours, and I hope we could make it since we started late. Now, we are glad to have the different institution representatives who will represent their respective schools. Now, I hope that we will be able to learn something from the session this morning, and we would have been happier if we had topics coming in relation to our disaster awareness. Unfortunately, since the disaster came much later than the papers that were done, so we have to make do with whatever was given to us. I would like to acknowledge also the efforts of the committee from inception to completion. So without much further ado, I would like to give the floor to the next speaker.
The reading of the contest rules, guidelines, and criteria for judging will be given to us by Dr. Corazon Meneses of Cebu Institute of Medicine.
Good morning, everyone. Good morning. Okay. To start with, there are two criteria for the judging of the research papers. The first one is the technical criteria, which constitutes 65%, and the second one is the actual paper presentation, which constitutes 35%. Under the technical criteria, it is broken into 20% for the originality of idea and appropriateness of methodology. Another 20% for potential for the creation of new or advancement of knowledge and evidence of benefit to the area covered by the research. And the remaining 25% is for the anticipated outputs, outcome, and impact of the research project, including potential contribution to economic and social benefits. So this morning, I'm going to give you the guideline of the second criteria, and that is the actual paper presentation. So number one, the presenter is allotted 20 minutes to present the research paper. Number two, the format of presentation is as follows. The project description, the objective of the project, methodology, results and discussion, conclusion, and finally, recommendation. Number three, green, yellow, and red lights are mounted on a table over there within the clear view of the competing researchers and the panel of judges. Number four, as soon as the green light is on, the researcher starts her presentation. Then the yellow light will warn the researcher that there are 30 seconds left before his time is up. Once the red light is on, the researcher is obliged to end his or her presentation, finished or otherwise. He or she then stands by for the question by each of the judges. Number five is immediately following each presentation is the question and answer session. There will be questions and answers after the other from each member of the panel of judges. One among the audience is privileged to ask one question. So only one from the audience. Number six, the three judges will tabulate the scores before submission, and the decision of the panel of judges is final. Number seven, the criteria for judging will include the following. So for the technical criteria, I'll go now to the actual paper presentation. The delivery which pertain to the clarity, understandability, concise reporting within the given time is 10%. The format presentation, and this pertains to clear description of the research following the given format cited before, is another 10%. And then the remaining 15% is for the researcher's persuasiveness, which means the knowledge about the research project and his or her communication skills, for a total of 35 plus the 65 technical criteria, for a total of 100%. So good luck to all the presenters.
Thank you, Dr. Meneses. Now we move on to the introduction of the members of the Board of Judges. And may I call on Dr. Judy Ann Jimena of the University of Cebu.
Okay, good morning everyone. Welcome participants from different parts of the Philippines. Okay, at this point I would like to introduce our judges for the oral research presentation student category. Our first judge is a graduate of UP College of Medicine and Rockefeller Scholar for Master of Science in Clinical Epidemiology. He is a faculty at the La Salle Health Sciences Institute College of Medicine, teaching in the Department of Bioethics, Pediatrics, and Clinical Epidemiology. A life member of the Philippine Medical Association. Please welcome the Vice Chancellor for Research of the La Salle Health Sciences Institute and a Chair of Region 4A Health Research Consortium. A round of applause to Dr. Melchor Frias IV. Our next judge was born in Tolosa, Leyte, a health sector specialist in health policy and health financing, local health system, and a good governance. She is currently the President and Chief Executive Officer of an NGO, Health Perspectives Incorporated. She is married to Dr. Leonardo A. Alcantara Jr. and a member of the Philippine National Health Research System Research Mobilization Committee. Help me welcome Dr. Maria Ofelia Ocaña Alcantara. Our last judge, but not the least, is an awardee of the UP College of Medicine Outstanding Research Publication Award. He has conducted researches funded by WHO, WPRO, IDRC, and USAID, Rockefeller, and World Bank. He is a current professor of the College of Medicine, University of the Philippines, specializing in clinical epidemiology and family and community medicine. An active member of the PCHRD structure, organization, monitoring, and evaluation committee. A round of applause to Dr. Noel R. Tuban.
Thank you, Dr. Jimena. To start our presentation, our first presenter will share with us their research entitled In Vitro Antiprotozoal Activity of Morinda centrifolia crude extract against Blastocystis hominis. Let us welcome Ms. Leslie Jane Vasquez from the San Pedro College, Davao City.
Human to human, animal to human, and waterborne transmissions. All this have contributed to the increased impact of Blastocystis hominis in public health. In our society, it is highly prevalent, especially in developing countries where it can reach as high as 76% of the population. It is even 48.7% prevalent among us Filipinos. But what is more alarming, ladies and gentlemen, is that this high prevalence of Blastocystis hominis is associated with the characteristics unique only to Blastocystis hominis. Relevant studies conducted by Zaki and Zaman, Mo and his colleagues, and Anwar and his colleagues in 2013 proved that Blastocystis hominis has the ability to resist chlorine at standard concentration used in water treatment and ability to survive well in water even up to 19 days. Lina Yuba and his colleagues in 2004 also proved that the cyst of Blastocystis hominis has are rather small compared to the cysts of other protozoa such as Giardia intestinalis and Entamoeba histolytica, allowing the cyst of only Blastocystis hominis to escape the conventional water filtration technique. Ladies and gentlemen, it has been years, decades, that the drug of choice in treating Blastocystis hominis infection is metronidazole. However, Zaki and Zaman, as well as Haresh in 2002, found out that Blastocystis hominis has the ability to resist the anti-protozoal action of its common treatment, metronidazole. Now confronted with these facts, the Department of Health challenges the scientific community, the research enthusiasts, the academe, us, to find for a new dimension in treating infections such as those caused by Blastocystis hominis using our country's rich yet unexplored flora, one of which is Morinda citrifolia. To the honorable panel of judges, my co-participants, guests, members of the academe, research enthusiasts, on behalf of DOST Region 11, the San Pedro College, the Medical Laboratory Science Department, and my co-researchers, I, Leslie J. Vasquez, I am pleased and honored to share with you the fruit of our labor, the research entitled In Vitro Antiprotozoal Activity of Morinda citrifolia Apatod Crude Extract Against Blastocystis hominis. This study aimed to explore the antiprotozoal potential of Morinda citrifolia Apatod Crude Extract against Blastocystis hominis. More specifically, this study aimed to determine the viability percentage of the test organism when exposed to the following treatments. First, the Morinda citrifolia crude extract. Second, metronidazole as a positive control, both given in the same concentration at 100 micrograms per ml and at different volumes, 25 microliters, 50 microliters, and 100 microliters. It also aimed to determine the significant difference between the mean viability percentage of the test organism when exposed to the treatments. In this study, the independent variables of the treatments, Morinda citrifolia, dried fruit crude extract, and the metronidazole as a positive control. These variables affected the dependent variable, which is the cell viability of Blastocystis hominis when exposed to the treatments. In the study, the antiprotozoal activity of the treatments were assessed by performing the viability count. If the crude extract exhibits antiprotozoal activity, the viability of the test organism when exposed to the treatment closely resembles that of the positive control. For the methodology, after getting the approval of the Ethics Committee, the Research Committee, and the Dean of the Medical Laboratory Science Department of San Pedro College, the researchers obtained Morinda citrifolia fruits and stool samples positive for Blastocystis hominis. The rectal smear with IED was performed, and the presence of the Blastocystis hominis was confirmed by Ma'am Rosmila Evale, the head of the Clinical Microscopy Department of Davao Regional Hospital. Representative samples of the fruit of Morinda citrifolia was also submitted for verification to Ateneo de Davao University and was verified as Morinda citrifolia by Professor Fe Magpayo Bagajo. The fruits were chopped into pieces, air-dried in shade in 1 week, then extracted using the rotary evaporator to obtain the truth extract. Oxidation test was performed to test for the presence of alcohol. In the test, there was no formation of green color within 15 seconds, and this signifies that the alcohol was completely removed from the truth extract, and the alcohol doesn't give or doesn't affect the antiprotozoal activity of the truth extract against Blastocystis hominis. 3-pH color test was also performed to test for the presence of iridoid, wherein the production of blue color confirms the presence of iridoid in the truth extract. But ladies and gentlemen, what is this iridoid? The study conducted by West and Deng in 2011 and 2012 confirmed that iridoid is the major phytochemical component of Morinda citrifolia. It occurs at the highest concentration, particularly in the dried fruit of Morinda citrifolia. This iridoid, according to relevant studies, exhibits neuroprotective, cardioprotective, hepatoprotective. It has immunomodulator activity. It is antispasmodic, anti-cancer, antioxidant, and anti-inflammatory. It exhibits bile acid chloretic action. It has purgative properties, and it has been proven to be effective against yeast and gram-negative and gram-positive bacteria. For the in vitro testing, lac solution and the egg albumin were used to prepare the lac egg medium. Now, the Blastocystis hominis were cultured using this lab-fed medium and was incubated for 48 hours at 37 degrees Celsius and in a strictly anaerobic environment. After which, 1 ml from the culture tube, the culture fluid were incorporated into different culture tubes containing 100 micrograms per ml of the treatments Moringa strifolia, dried fruit extract, and the metronidazole. These tubes were incubated for 48 hours and 96 hours, and after which, the antiprotozoal activity of each treatment was assessed by obtaining 1 ml from the culture fluid and performing the viability count using eosin green and Kristine blue. This eosin green and Kristine blue stained the live cells and the dead cells of Blastocystis hominis. The live cells were stained green, while the dead cells were stained red. For performing the viability count, formulas were used. For the viability percentage, we used 3 formulas. First, to compute for the cells per ml, the average count per square was multiplied by the dilution factor into the constant of 10 raised to the power of 4. For the total cells per ml, the cells per ml was multiplied by the original volume of the culture fluid, that is 6 ml, and for the percent viability, the total number of viable cells was divided by the total number of both viable and non-viable cells and was multiplied by 100. The data gathered in this experiment was statistically analyzed, and the resulting mean viability percentage of the test organism when exposed to the treatment are shown in these graphs. As you can see, at 25 microliters, after 48 hours of incubation, the viability of the test organism Blastocystis hominis when exposed to metronidazole is 87.54%. While when you compare it to the apatot as a treatment, the viability is 27.63%. Here, it tells us that both treatments, Moringa strifolia, fruit extract, and the metronidazole were able to control the multiplication of Blastocystis hominis. But when we compare the two with metronidazole as a treatment, the viability of the test organism is 87.54, meaning 87.54% of the cells remain viable. While when we compare it with the viability using apatot as a fruit extract, the remaining viable cells is only 27.63%. Now, after 96 hours of incubation, the viability of the test organism decreased. Using metronidazole as the treatment, the viability is 38.95%. When we compare it with the apatot fruit extract, the viability is only 20.94%. At 50 microliters, after 48 hours of incubation, the viability of the test organism when we exposed it to metronidazole as a treatment, it's 63.69%, compared with a viability of 13.68% with apatot as a treatment. After 96 hours of incubation, the viability still decreased. When we use metronidazole as a treatment, the viability is 16.97%, compared with a viability of 11.35% using apatot as a treatment. At 100 microliters, after 48 hours of incubation, the viability of the test organism when exposed to metronidazole is 40.74%, compared with the viability of the organism when we compare it to apatot, the viability is only 8.07%. After 96 hours of incubation, the viability of the test organism still decreased. As you can see, with metronidazole as a treatment, the viability decreased to 9.43%. But when we compare it to apatot fruit extract, the viability dropped to 0.90%. Now here, the results of the mean viability percentage tells us that both treatments, Moringa strifolia, dried fruit extract, and the metronidazole as the positive control were able to control the multiplication of Blastocystis hominis. Hence, they exhibit antiprotozoal activity against Blastocystis hominis. The viability percentage of the test organism decreased as the duration of exposure to the treatment increases. The viability decreased as the duration of exposure to the treatments increases. But when we compare the two treatments, there is a lesser viability and a more pronounced decrease in the viability percentage when the treatment used is apatot fruit extract. But the question here, ladies and gentlemen, is that is there a significant difference between the mean viability percentage of Blastocystis hominis when we exposed it to the treatments? Table 1 shows us that in using t-test, there is a significant difference between the mean viability percentage of the test organism when we exposed it to metronidazole and apatol crude extract for 48 hours. Here, there is a p-value that is lesser than 0.05 level of significance. Particularly, it's 0.0044 and 0.0201, 0.0445 at 25 microliters, 50 microliters, and 100 microliters respectively of 100 micrograms per ml of the treatments in favor of metronidazole. This means that the Blastocystis hominis were able to survive in metronidazole, or this means that using metronidazole as a treatment, more Blastocystis hominis were able to survive using metronidazole. But when we convert it to the context of antiprotozoal activity, the apatol crude extract was able to control more Blastocystis hominis than metronidazole. Then after 96 hours of incubation, the table 2 shows us that in using t-test, there is a significant difference between the mean viability percentage of the test organism when we expose it to the treatments metronidazole and apatol crude extract. Here, the p-value is lesser than 0.05 level of significance, particularly at 25 microliters and 100 microliters, it's 0.0328 and 0.0138 respectively. The results of the t-test tells us that yes, both treatments exhibit antiprotozoal activity. They were able to control the multiplication of Blastocystis hominis. However, when we compare the two treatments, as you can see, ladies and gentlemen, if we take 25 microliters after 48 hours of incubation and 100 microliters after 96 hours of incubation as example, the mean viability percentage of the test organism is 87.54 using metronidazole, and it was able to control 12.46% Blastocystis hominis. But when apatol crude extract is a treatment, the viability is 27.63%, and it was able to control 72.37% Blastocystis hominis. Then at 100 microliters after 96 hours of incubation, the viability of the test organism using metronidazole is 9.43%, and it was able to control 90.57% Blastocystis hominis. When we compare it to the apatol crude extract, the viability is 0.90%, and it was able to control 99.1% of Blastocystis hominis. This tells us that Blastocystis hominis are controlled by the two treatments, but apatol was able to exhibit higher and antiprotozoal activity than the positive control metronidazole. This leads us to the conclusion that Moringa citrifolia apatol crude extract exhibits antiprotozoal activity against Blastocystis hominis just like the positive control. However, at certain concentration and at certain duration of exposure to the treatments, it exhibits better and faster antiprotozoal activity than the standard drug metronidazole. The findings of the study, based from the findings of the study, the researchers recommend that the antiprotozoal activity of Moringa citrifolia dry fruit crude extract be tested against Blastocystis hominis from animals. Then perform in vivo testing using animals as subjects. Now, the plant extract should be used with other parasites, especially Entamoeba histolytica. Use HPLC for the identification and isolation of the iridoid from Moringa citrifolia. Compare the extract of Moringa citrifolia with other antiprotozoal drugs aside from metronidazole, and conduct further studies about Moringa citrifolia. Ladies and gentlemen, the high prevalence rate, high survival in water, ability to survive well in water, ability to resist chlorine at standard concentration, and ability to resist the antiprotozoal action of metronidazole together contribute to the alarming problem that Blastocystis hominis give on the public health. However, the nature gives us a potential remedy, and that is through Moringa citrifolia. This Moringa citrifolia, based from other people, they consider it as just a plant growing everywhere at the shorelines of the Philippines and Southeast Asia, without even knowing that even before the emergence of drugs, people in old times used it to treat boils, carbuncles, inflammation, sore throat, and infection, without knowing what is in Moringa citrifolia, what is behind the miracle of this fruit. This study is perhaps the first research conducted about the antiprotozoal activity of Morinda's trifolia against protozoans such as Blastocystis hominis. Based from the findings of the study as well as relevant studies, Morinda's trifolia contains iridoid, and iridoid is responsible for its purgative property, choleratic property, antimicrobial property, and antiprotozoal activity. Let us use this information, let us use this knowledge to find for a new dimension in treating infections such as those caused by Blastocystis hominis using Morinda's trifolia, a plant not known to anyone or not known to everybody, but is a potential remedy. It can be used as a potential agent for finding for a new dimension in treating infections such as those caused by Blastocystis hominis. That's all. Thank you.
Thank you, Ms. Vasquez, for sharing to us your findings in that research. I'd like to call on Mr. Christian Anuta, who is our moderator.
Morning, everyone. We would like to press Ms. Vasquez to remain on the podium. Thank you, Sir Robert. We will give each judge one question to ask to the presenter, and then after that, we will ask one audience member to make a clarification or a question to our presenter. So, who would like to go first? Dr. Alcantara.
Thank you so much, and thank you also for your presentation. As I was reading your research, it excites me that because I usually in terms of protozoan is looking at the most common is the amoeba.
Yes, yes.
But this is a good immunization study that looks at this protozoan that's mostly affected with the amoeba, and probably people that handles the amoeba. I would like to ask you in terms of, in your conducting your research, what were the risk factors that you were able to face, and how did you manage it in terms of the research? And then in terms of risk. The second is, how do you want the research to proceed? Because at this point, it cannot be used still for human purposes. So how do you want this to proceed? Because a conduct of further study of the apathogen, and apparently there's a medicinal or effectiveness of this apathogen, but how do we correlate this and introduce this to humans in terms of management of the protozoal infection, especially as I see it, that you all would like to replace metronidazole in this region.
Thank you for the question, Doc. For the first question about the risk factor, when we conduct the study, of course, people have been throwing questions to us, why blastocystis, why blastocystis? But as we conduct the study, the first is where will we get the blastocystis hominis? We search for different hospitals. However, a lot of hospitals are not reporting blastocystis hominis, and we are aware about that. But we found Davao Regional Hospital, and we were able to talk with Ma'am Rosmilda Abale, and she confirmed that blastocystis hominis is really prevalent, especially in the Davao Regional Hospital, where blastocystis hominis are always reported every week. We get blastocystis hominis stool samples there, and for the procedure, we conduct the culture in Davao Regional Hospital, of course, with using the PPE and using with Ma'am Rosmilda Abale as a mentor, as well as Ma'am Jazzy. For the second question, how we want it to proceed. Of course, people infected with blastocystis hominis exhibits symptoms the same with Entamoeba histolytica. This study can help them to find for a potential home remedy for the gastrointestinal symptoms that they are experiencing. It could be through the ingestion or drinking of the noni juice, and or also for eating the Moringa citrifolia fruit.
Thank you. So we have other two judges, Dr. Hooper. Yes. We're actually pointing at each other. Dr. Reed.
Congratulations for that presentation. I think that's a model for other presenters, as you presented extemporaneously, and you looked at the audience all the time.
Thank you.
On the paper, you said that the blastocystis hominis was taken from Davao Regional Hospital,
Yes.
and you said that there's increasing prevalence.
Yes, ma'am.
If there's increasing prevalence, you mentioned also that there's increasing resistance.
Yes, ma'am.
Did you find out what is the resistance pattern of blastocystis hominis to metronidazole in Davao or in that particular hospital?
No doubt.
How do you think would this have affected your results if ever the blastocystis were indeed resistant to metronidazole?
Now, if when you consider the factor that the blastocystis hominis has the ability to resist metronidazole, the atoprazole of metronidazole, we compared the viability of blastocystis hominis with crude extract. And if there is really a factor that blastocystis hominis is able to resist antiprotozoal action of the metronidazole, it could the results of the study tells us that more blastocystis hominis were able to survive using the metronidazole as a treatment.
But that would depend on the subtype of blastocystis hominis.
And
We have subtypes, and specific subtypes are resistant to metronidazole, specifically subtypes 7 and 4. So you would have probably also take into consideration the subtypes.
Yes, sir.
And the resistance has been noted since 1991, and it's increasing, specifically to metronidazole. Probably you could also have other positive controls, like what we're doing now clinically in practice is, aside from metronidazole, is giving also cotrimoxazole and other drugs, which were found to be more effective than metronidazole, because metronidazole does not completely eradicate infection. That's all. Thank you.
Okay, thank you.
Okay, thank you, Doc. So for students who are trying to make a similar study, you should take into consideration the comments of Dr. Frias, try other medicines and try to identify the subtype. Okay, so for the last judge, Dr. Hooper.
Okay, my comment is also a question is that when you justify your study, you will be looking for numbers, and you say that when you say the prevalence is high, you should give us what is the prevalence, and there's a national prevalence, because we are thinking that this is really worth it because this is a problem. But you can also do a study because it is high in a specific population, rather than say that it is growing, because we would also need numbers in trends.
Mm-hmm.
And if you have data like a study in Malaysia, we'll be looking more for data coming from a local study, like the Cyrus book that you probably quoted. And also, when you make that recommendation, plant extract should be used with other parasites, especially with Entamoeba histolytica. I think logic dictates that if it works with a parasite, it might not work for this one. For Intaliva or Antibiasis. So we're looking more on that. And I think one comment is you failed to show us the pathophysiology of blastocystis for us to really comprehend why you need to do this study. How does it affect humans? Because mainly we see it in animals, it is transmitted, and so data that it is about 20% in immigrants in Taiwan among Filipino migrants. So that's, you have to show us that the problem really exists and the magnitude of the problem. Whether it is low, it's high, whether it's low, but it affects an indigenous population or a special population that needs to be taken.
For the prevalence talk, we based it on the study conducted by Anwar and his colleagues in 2013. It showed that blastocystis hominis infection is prevalent, especially in developing countries, that's 76%. And for the Filipinos, it's 48.7%. But for the locality, there's not yet any existing researches about the prevalence of blastocystis hominis.
Okay, one more question. In the dilution that you did you also dilute the metronidazole?
Yes, sir.
Do you need? Why did you dilute the passive control that you are using? We were just testing the amount of, and when you say that this is not common, is this not the same as noni and the noni use that we know?
I mean, sir, Doc, we gave both treatments at 100 micrograms per ml. Same concentration. Only at this point.
Okay, no dilution for that. Can we have one question from the audience? I saw raise your hand first. A reminder, please state your name and your institution before asking the question. And please use our microphone. It's in the middle of our session hall.
Good morning. Good morning. I'm Dr. Pandilio from LAS University Foundation. One of your recommendations is the use of HPLC for the identification and isolation of the iridoid. I'm just curious why very specific on iridoid, where in fact there might be some other bioactive constituents that might be present to have anti-protozoal activity.
Yes, so based from the study conducted by West and Deng in 2011, it showed that blastocystis, Morinda citrifolia dried fruit extract contains the major phytochemical component iridoid in its dried fruit. So when we used it, the antiprotozoal activity of the dried fruit extract of Morinda citrifolia might have affected the antiprotozoal activity more than the other agents present in the Morinda citrifolia dried fruit extract. And we also performed cranial color test, which signifies or confirms that iridoid is really present in the fruit extract of the Morinda citrifolia.
Yeah, if I may suggest, you might as well do the bioassay directed isolation. That is, if it is active, then you isolate that active component from a specific fraction. Not yet identifying that this is iridoid, because you are eliminating the possibility of discovering other major constituents.
We would also like to do that when we proceed with the study. However, we were not able to do it because of the limited techniques, limited instruments found in the locality. But if given the chance, if there are techniques, more instruments for that particular technique, we will really do it for this research.
Okay, thank you, Ms. Astas. We are actually running on 30 minutes, so thank you for that. Before we go to our next presenter, I'd like to announce that the snacks is actually ready outside, so you may go out to get your snacks and then come back, meet the after for the next presenter.
Thank you very much.
Thank you, Ms. Vasquez. We have heard about Morinda centrifolia. Now we have to hear another presentation, and the title is Nephroprotective Effects of Cogon Temperata Cylindrica Root Aqueous Extract on Sprague Dawley rats with gentamicin-induced acute kidney injury. Let us welcome Mr. Junel Poblete from the University of the Philippines, Manila College of Medicine.
Hi, good morning, Cebu. Good morning, judges, to our participants and the audience. So, I'm Janelle B. Poblete. I'm from the University of the Philippines College of Medicine, and I'm here to present a research study entitled The Nephroprotective Effects of Imperata cylindrica aqueous root extract on Sprague Dawley rats with gentamicin-induced acute kidney injury. So acute kidney injury is the sudden impairment in the kidney function, such as an increase in the blood urea nitrogen and or an increase in creatinine levels. It is a major medical complication in the Philippines, and it is associated with increased mortality and cost of care. Actually, data from the Intensive Care National Audit Research Center last 2005 shows that AKI accounts for about 10% of all intensive care unit bed days. Thus, immediate and cost-effective treatment for AKI must be in place. So AKI is primarily mediated by oxidative stress. This leads to direct cellular damage and mesangial contraction, leading to the vasoconstriction of your afferent arterioles. Therefore, antioxidants which are able to sequester these reactive oxygen species may confer protection against AKI. So Cogon is the most common grass species in the Philippines and is found to possess antioxidant and anti-inflammatory properties. Moreover, it has been used by different ethno-linguistic groups such as the Ibatan, Aitas, Ifugao, and Higaonon for kidney problems due to its diuretic action. However, there is still limited scientific data on its nephroprotective activity. Therefore, this study aims to determine the nephroprotective effect of Cogon root aqueous extract among male albino Sprague Dawley rats with gentamicin-induced acute kidney injury. Specifically, we want to determine the kidney weight to body weight ratio, the serum creatinine and blood urea nitrogen levels, and the histopathological features such as glomerular congestion, blood vessel congestion, interstitial edema, inflammatory cells, and the presence of necrosis and tubular casts. For the methodology, Cogon roots were first harvested from Cavite, authenticated by the botany section of the National Museum of the Philippines, cleaned and air dried for 24 hours. A decoction was also made using distilled water. The extract was then lyophilized and reconstituted, sent out for phytochemical screening. Okay, so the procedures involving animal care and use were reviewed and approved by the Institutional Animal Care and Use Committee of the National Institutes of Health in UP Manila. 15 rats were randomly assigned to 5 groups, with 3 rats each. So we have a negative control, we have a positive control, and 3 treatment groups: Cogon 100, Cogon 500, and Cogon 1000. So after acclimatization of 2 weeks, oral treatment was started that lasted for 17 days. Control group received normal saline daily, while the treatment groups were given 100, 500, and 1,000 milligrams per kilograms of Cogon. So how did we know how long we will be inducing the acute kidney injury? So we made a pre-test before the study, so that we want to determine when is the right time to sacrifice the rats to determine when is the significant kidney damage was observed. So AKI was induced using gentamicin, and the rats were serially serially sacrificed in days 5, 6, 7, 8, 9, 10. And the days of administration and the 10th day of administration of gentamicin actually led to the most significant kidney damage. Therefore, the duration of induction of AKI lasted for 10 days. Okay, so AKI was induced from day 8 to day 17, and the gentamicin group and the 3 triplet groups received daily intraperitoneal injections of gentamicin, while the control group received intraperitoneal normal saline. Now, if you ask me, how did we determine the concentration of the cogon that we will be given without administering toxicity to the animals? So, previous subacute and acute toxicity studies were already performed, and this gave us the value of Kogan 100, Kogan 500, and Kogan 1000. So on day 18, the rats were sacrificed. The kidneys were harvested, weighed and preserved. Blood samples were taken for serum cream, blood urea, and nitrogen, while the kidneys were identified for the different pathology present in it. Okay. So the histopathological features were graded using the histopathological feature scoring found in our paper. So for the results, that's the scoring that we used. So for the results, the mean kidney weights of Kogan 100 group was found to be significantly higher than the control group. These findings are consistent with previous literatures showing that AKI may manifest as an increase in kidney weight due to interstitial edema, post-injury triglyceride accumulation, and ammonia accumulation that stimulates epithelial hypertrophy. For the renal functional parameters, Kogan 100 and Kogan 1000 showed a significant decrease in serum creatinine levels compared to the positive control. For BOM levels, our crystal Wallace test actually revealed that there is no significant difference among treatment groups. However, as we can see in these graphs, there is a dose-response relationship between the renal function parameters and the amount of Kogan administered. So, for the histopath analysis, no interstitial edema was observed for all groups. So these arrows now point to your glomeruli and your renal tubules with numerous red blood cells. This slide shows outright necrosis of your tubules, while this one shows the infiltration of inflammatory cells such as neutrophils and monocytes in the interstitium. RBC casts were also present in the distal tubules. And lastly, hyaline casts were noted in the distal tubules of your positive control, Kogan 100 and Kogan 100, but less affected tubules in your Kogan 1000 compared to your positive control. So this means that the increase in hyaline casts corresponds to the early stage of AKI, and a significant dose-dependent decrease in the hyaline cast upon administration of your Kogan may support a possible nephroprotective effect of Kogan. So how does Kogan confer its nephroprotective effect on AKI? So these are the following reasons that we come up with. So AKI stems from the changes in the renal microvasculature that results to a reduced glomerular filtration rate due to oxidative stress and inflammatory changes. The nephroprotective property of Kogan now may be due to its antioxidant and anti-inflammatory activities. To support this, we actually performed a phytochemical analysis of the extract, which revealed the presence of glycosides, of antioxidant flavonoids, and reducing substances like ferritin, which may actually prevent oxidative stress. So in conclusion, Kogan was found to decrease kidney weight, blood urea nitrogen levels, serum creatinine levels, and hyaline cast in a dose-dependent manner. For further studies, we recommend identification of the different active constituents of the extract, addition of specific biomarkers related to oxidative damage and acute kidney injury, and doing a urine output analysis and urinalysis for further studies. And that's it. Thank you. I'm done with my presentation. I hope you learned something new today.
Okay, same step. Now we start from Dr. Frias for the question.
Congratulations for the paper. I think the paper is well written and it has technical merits. So in terms of those technical merit and how it was written, I commend your group for doing such a research. But you did not mention in your oral presentation the limitations that you mentioned in the paper, and one of the limitations is the sample size, which actually affected your results because it affected the Kristine test, right?
Yeah, actually, sir, according to our team, we were able to compute for our sample size, and we were able to reach the sample size required for this study. However, our theory was that maybe the reason why there is no significant difference observed in terms of the blood urea nitrogen and protein concentration was that we needed more samples or rats involved in this.
Yes, I'm going to that point because in the sample size calculation, you use the resource equation.
Yes, sir.
And in the resource equation, you use the lower limit for the E, right?
Yes, sir.
Why did you decide to choose the lower limit when you could have chosen the upper limit of 20 and still that would still be acceptable?
It was actually a logistic limitation, sir, because during that time there was actually a scarcity of rats, of third generation rats from our suppliers, and we can't find any. We wanted to increase our sample size, yes, but sad to say we weren't able to procure enough.
What about, you did not use a blocking, right? You put that as 0. What about using blocking? For example, a block of 6. So the decision in terms of the sample size, your decisions regarding the sample size would have had significant effect on the results of your study. And it sort of decreased the technical merits.
Okay. Thank you, Dr. Frias. Here from Dr.
One of the outcomes that we measured is to readings. How many readers were, how many readings and how many readers were?
Sir, we actually employed one expert pathologist in renal diseases, Dr. Rita Tuazon. So she was the one who read all our slides, and she was the one who graded them.
Was there blinding done?
Yes, sir. She wasn't aware of the results of the study.
So when you gave her the specimen,
yes, sir.
Because you did not mention it. One of the things that you should also mention in terms of research, especially this is basic research, is how are bias controlled in this kind of study? Because say it's hard to, but if you have some outcomes such as that can be biased, the objectivity or knowledge of what is the exposure of the sample at hand, you should specifically mention it. You control this one, and there was this. Readers were not aware of what exposure.
Thank you, Dr. Ruben, about controlling bias and objectivity in research. Now, Dr. Kanya.
Thank you. I was reading your research, very voluminous, and I appreciate when doing, especially the literature review. I have just 2 questions. One is in terms of process, because we're also looking at improving the process of research. And the second is affecting the study itself. One on the process, in getting the ethics committee approval, how did you have difficulty or how easy was it to get this approval?
It was actually hard because the IFO, the in charge of the animal care, are actually requiring us a lot of things, like based on international standards. So we had to really comply on that before they give us the go signal to proceed with our study. So it was a matter of complying to their requirements, and we were very happy to follow them.
It was not that difficult.
But it is difficult, but we found ways to make it easier for us.
Okay, thank you. The second is, I really appreciate you because Congo is anywhere in the Philippines will happen. And I'm just looking at, because right now, the PITAT, they have actually approved the banaba as one of the good protection for our kidneys. Did you look at that also this angle of Wobon and the banaba extract to have top purification, or is this part of your recommendation for future research?
We actually didn't look at banaba because this research was done like 3 years ago, and the banaba study was just recently approved. So we during that time when we were doing it, we weren't able to see a correlation between the two. So that's why we only did a study on colon.
So the banaba has been approved by the traditional group medicine, that group, as actually a medicine itself. So it has already in terms of efficacy and effectiveness, it's already there. So I'm just looking at, because this could be a complication. Yes. And this could be probably, if we mix both, we have 10, most both, but the effect would be better. That I'm just looking at it. Because this could be, maybe it's not just banana, and then maybe other diuretics also, but we also we use for compensation in the management of acute kidney infection.
Thank you for that recommendation. I also believe in that the synergism of different medicinal plants can actually lead to better results. So thank you, ma'am, for that recommendation.
Thank you, Dr. Researchers, most importantly, have to be relate with the subject. So that's a very good observation. Okay, shall we have one question from the audience? I don't see any hand. I see you, but anyone else? Okay, can we have a doctor from Angeles University College again?
Actually, I'm very interested in looking for other sources. Now I'm just trying to know how did you come up with getting cogon root as your source? What made you select it? Is it because of its antioxidant property?
Actually, it was the first thing that we did is we were looking for plants that were being used by ethno-linguistic groups, and we found this article saying that these ethno-linguistic groups are actually using cogon for its diuretic property, and that sparked the curiosity. Like, really? So maybe we can study this plant and check its nephroprotective activity. So that's what happened.
But the question is why root?
Why the root? Oh, we actually saw some journals, it's an article, saying that the rhizomes and the legumes actually contains the highest anti-inflammatory and antioxidative property. Actually, some studies were able to, which screened the different parts of the colon, so that they're really concentrated in that region. So that's what we use.
So there were tests already about the different parts of the plant?
Yes. Yes, and so phytochemical screening on the different parts of the plants were already done. Before, actually, there have been conflicting studies on the diuretic effect also of colon, but none on its nephroprotective effect.
But with the other parts using this test?
No, we just use the roots.
Okay. Because I'm just wondering, baka meron sa dito higher than other parts. And because you're killing the plant already, you're getting the roots. And yung gives kasi more contains phytochemicals because of its ethical consideration behind consider when it comes to preservation of.
Maybe a good modification of the study is to actually harvest the different parts and check if they have the same natural protection.
Yes.
Thank you.
Okay, thank you. Thank you, Sir Pomada.
Thank you so much. Have a nice day.
Thank you, Mr. Poblete. Our third presenter will share with us a study entitled Mangosteen Extract, a comparable anti-angiogenic substance to bevacizumab on duct chorioallantoid membrane. Let's welcome Ms. Elizabeth Grace Alcazar of the Cebu Institute of Medicine.
Good morning, everyone. As we are aware, cancer is one of the leading causes of mortality and morbidity in our country. Various regimens have been used in the treatment of cancer, and anti-angiogenic drugs are one of them. Anti-angiogenesis or anti-angiogenic agents interfere with the formation of the tumor blood cells, leading to their death by starving these cells of their blood supply. However, these drugs are very expensive and they are associated with a multitude of side effects. Thus, a cheaper and safer alternative is warranted. And so we turn to herbal medicine as an alternative source. Among local plants native in our country, mangosteen has shown promise as an anti-angiogenic agent based on an in vitro experiment conducted by Shiozaki and colleagues. And so we chose mangosteen for this study. Esteemed judges, honored panelists, guests, ladies and gentlemen, good morning. I present to you this study entitled Mangosteen Extract, Comparable Anti-Angiogenic Substance to Bevacizumab and the Chorioallantoic Membrane. Our main objective is to determine whether a mangosteen extract assesses comparable anti-angiogenic activity on the embryo chorioallantoic membrane against bevacizumab or the brand name Avastin. Specifically, we wanted to determine the median number of blood vessels within a 6 mm disc prior to the exposure to the test substances, and we also wanted to determine the median number of blood vessels formed among the sterile 0.9 sodium chloride solution or the normal saline solution NSS group, which is the negative control, the bevacizumab group, which is the positive control, and the mangosteen extract group, which is the experimental group, within the same 6 mm disc size. We also wanted to determine the median number of blood vessels between the pre-exposure and post-exposure group. We also wanted to determine whether there is a significant median difference in number of blood vessels between pre-exposure and post-exposure among the three groups. This is an experimental design of controls, and we conducted the study in various laboratories in our institute. The test subjects were 12-day-old duck embryos of fertilized Cairina moscata or muscovy duck eggs. We utilized simple random sampling, and the total subjects were 72 duck embryos each. In our maneuver, we first prepared the extract. This is a picture of the extract that was being dried or evaporated to dryness. We were able to do this after drying the mangosteen pericarp and concentrating them using 400 ml and extracting them using 400 ml 95% ethanol, and then we filtered and concentrated and then we evaporated to dryness. And so the result here will yield an approximately 1 gram orange-brown yield. And for this, we took 500 milligrams or 0.5 gram of the mangosteen, and which we weighed, and we diluted with 0.5 ml of 95% ethanol. This will give us with approximately 100% concentration, and 0.02 ml was placed on individual sterile discs to be applied later on to the chorioallantoic membrane. We then use 0.9% sterile sodium chloride, which is our negative control, and 0.02 ml was given. And for the bevacizumab, for our positive control, we also computed 0.026 ml to be given, and approximately that amount was also applied to the sterile discs. We then cleaned and numbered the eggs, and we cleaned them using 70% ethyl alcohol, and we weighed the eggs. And then you open the eggs at the blunt end, creating a 15 millimeter diameter hole. We then infused this on the exposed chorioallantoic membrane and reincubated the eggs for 48 hours. After which, we cut open the eggs, we cut them crosswise and allowed the embryo to slide away so that we can breathe the chorioallantoic membrane. And then the blood vessels within the 6 millimeter discs were counted. In the data analysis, to determine the significant differences in group medians at pre-exposure and post-exposure, and also to determine the differences in median difference in number of blood vessels between pre-exposure and post-exposure among three groups, we used Moore's median tests. The results of our study showed these three pictures, which are examples of the chorioallantoic membranes of the embryos treated with the three substances. Picture A will show the chorioallantoic membrane of a duck embryo treated with NSS, which shows 17 branches. Picture B was treated with bevacizumab, and it had the presence of 2 branches. And picture C was treated with the mangosteen extract, and it had 4 branches. Our results will show that upon pre-exposure, our baseline, where we counted the number of blood vessels on the 6 millimeter disc before applying the test substances. Those eggs within the NSS group had a median of 3 blood vessels with a 95% confidence interval of 1 to 7.4. Bevacizumab had a median of 3 with a 95% confidence interval of 1 to 4. And mangosteen had a median of 2 with a 95% confidence interval of 1 to 3. The p-value of these three groups at this point was 0.086, meaning that there is no significant median difference. At post-exposure, or at 48 hours after exposure to the test substances, the NSS group had a median of 11.5 with a 95% confidence interval of 2.15 to 21.7. Bevacizumab had a median of 5.5 with a 95% confidence interval of 2 to 11, and mangosteen had a median of 6 with a 95% confidence interval of 2 to 11. At this point, the p-value was 0.006, which meant that there was a significant median difference at this point. We computed the difference between the pre-exposure and post-exposure groups, and NSS had a 95% confidence interval of negative 0.85 to 18. Bevacizumab had a median of 2.5 with 95% confidence interval of negative 1.75 to 9.75. And mangosteen had a median of 4 with a 95% confidence interval of 0.15 to 9. At this point, the computed p-value was 0.048, which showed that there was a significant median difference. So what does this tell us? It tells us that the effects of these three substances are not equivalent with one another. NSS lacks any documented anti-angiogenic effect, thus it was expected that it would not inhibit angiogenesis. So it simply did not inhibit angiogenesis or the formation of blood vessels. Bevacizumab clearly demonstrated anti-angiogenesis, and mangosteen also demonstrated anti-angiogenesis. Based on our operational definition, we then conclude that mangosteen has comparable effects with that of bevacizumab. For our recommendation, we recommend that a larger sample size will be utilized in further studies so that future studies can arrive at a more conclusive result. We also recommend that isolation of alpha-mangosteen and other xanthones be used so that we can identify which of these xanthones are also active against angiogenesis. We also recommend that testing for anti-angiogenic effects using different concentrations be used, since only one was used in our study. And last but not least, we recommend that future researchers should also use stereo microscope in the analysis of their vascularity. And I just like to flash our references, and these are just some that we use in our study. Thank you so much for your time.
Okay. Thank you, Ms. Osar. Shall we begin with Dr. Ubar?
Um, how did you choose the site to measure in terms of vascularity? Is there a standard way or site that you need to measure? Because you mentioned here in your paper that there is a potential bias as well because only one researcher was reading. When did you come up with this one? Is this something after or is it something that you had thought before?
For the bias that we were able to identify, we identified that after we conducted the study. And to answer your question as to the site, when you apply the disc on the chorial lactoic membrane, it will actually just stay there. And unless you move it a lot or you physically remove it or if you just move it, then that's the time that it would be dislodged. But so long as you put it there on the chorial lactoic membrane, it will just stick there. So after 48 hours of incubation, that disc will just remain there, and that is still the area where you can count. So it is clearly, marked by the 6 millimeter disc.
You mentioned in your recommendation that you're recommending for a larger sample size.
Yes.
So when you did the numbers 72, 24 or something in the third group, was it based? What was the basis for that computation?
We utilized, we computed that based on the testing for sample size of two, using two. I got that for you. I'm sorry. But it was stated in our paper. Yes, that one. And we used the medians from previous studies as basis. The thing here is, since what we got was actually quite small, only 72, and the data was very skewed upon our data analysis. So we realized that a bigger sample could have shown us a stronger result or a more robust
data. Did you compute it yourself?
Yes, we computed.
Yeah, because usually, sample size computation, it gives you a number per group.
Yes.
It's not 70.
It's not
might
72.
Not be 72 divided by 3. 70.
No, I'm sorry. What we computed was 24 subjects per group, and so a total of 72 subjects was used in the study.
But you have 3 groups.
Yes, 3 groups, so 24 times 3. 72, right?
Well, there's some form of adjustment if you are comparing 2 groups. You can just add another group at the same number.
Yes.
So probably you should have considered that. And hopefully in the next studies, you employ the help of the experts in biostatistics or statistician in the conceptualization stage, so that you will not be surprised at the end that that sample size is not adequate, because that's why we also work with them in our research, be it basic or be it clinical research.
Yes, Dr. Ruben, that's a point well taken. But I'd like to let you know as well that in our study, we actually consulted 2 statisticians and 1 biostatistician. And it was, again, at the start, and eventually as our study progressed, Typhoon Yolanda came along and killed our supply of ads, so we were not able to to use a bigger sample size. So we just were only able to use what we were able to get our hands on, which is the 72 maximum. But we will certainly take that into consideration.
Okay. Shall we give the floor to Dr. Aka?
Thank you again, and congratulations for the presentation.
Thank you.
And I find this very interesting, especially that we are now the increasing trend of cancer, and it's very expensive. and this could be a very good, sort of part of the interventions for the treatment of cancer patients. There again, I just go process and the effect. In terms of process, because I look at it, there's still a lot of things that needs to be done to make this sort of accepted and be part of the policy that this mangosteen that cure cancer will be part of the traditional medicine. So in terms of process, your next step, are you looking at working with PTAC of that tax agency of the Department of Health that would help you further flourish your study?
That is a possible step, though. At the moment, what we were so focused on was to first confirm the trend that we were able to see in our study, since I'm not sure if we mentioned it in our paper, we were limited by our smaller sample size. So maybe in the future, if there are further studies with bigger sample size that can really, that can strongly conclude that mangosteen has anti-angiogenic effects, then the next step will be to partner with other agencies.
In terms of, I'm just concerned on the selection of your, the use of the eggs, especially now because of this GMO thing, because it could affect your study. We have some false effect in terms of what you want to see in the study. So how did you make sure that the egg that you use are the ones that will give you this result?
Well, for this, technically just the avian choriolentoic membrane was sufficient, since the assay that we use is just that, the choriolentoic membrane assay. There's no specific study on which species will give us better results. What is important in our study for our in vivo study is just that we need a biological being, a unique and living being to show the effects of angiogenesis on a developing creature. So this is in a way a preliminary study, and it was made to confirm the research that was done by Shiozaki about the anti-angiogenic effects in vitro. So we just used this since we were able to see on our research that there's no specific species that is superior. What's just important is that it is an avian choriolentoic membrane, and it has been studied that it is appropriate for this assay. So we were able to choose one that was also available.
Thank you. As researchers, the research output should not stop after you graduate. You do it even if you're a regular professional. So in the academy, we call it publish or perish. So that should also be practiced in the professional field. Okay, so we now go to Dr. Frias.
I agree that the paper is promising and the topic is interesting and has a lot of promise in terms of drug development later on. I actually have a lot of questions, but I'll ask two of the most important. The number one is, did you try to find out the mechanism of action of the mangosteen extract in previous literature as regards its anti-angiogenic effects?
We appended that in our appendix, in our conceptual framework. The study by Shiozaki, they were able to conclude, or they were able to surmise that mangosteen interfered with anti-angiogenesis by interfering with the VEGF pathway.
So is that the same mechanism of action of avastin?
Yes. We chose avastin in our group to be the positive control because they interfered in the similar VEGF pathway on angiogenesis. So we felt that if we chose a substance that had similar effects, then most likely the one that was more potent will really show the effects.
Because in related literature, it says that Avastin or bevacizumab has a direct action compared to that of if your mechanism is EGF, that would be indirect.
It has two actions. It interferes with the VEGF pathway by it inhibits the attachment of the VEGF receptor, so it works that way. And the second effect is it will lead to the sorry, I forgot the second effect. But technically, yes, bevacizumab was more into direct. It directly
It affects the CAM blood vessels, the rapidly growing CAM blood vessels. That's the other approach.
Yes.
And then, why day 12?
Sorry?
Why did you choose day 12?
For the previous studies using chorioallantoic membrane, the avian chorioallantoic membrane had used days 8 to 10, which were the days these. If we compare it to the chicks, these were the pro-androgenic stages. However, the muscovy ducts will actually develop at a later stage. So based on our study, we were able to see that day 12 muscovy ducts were equivalent to the day 8 to 10 chick embryos. So at this point, whatever substances we apply, they can clearly show androgenic or anti-androgenic effects. Because at a later stage, it may be too late.
Yeah. Did you write that in the paper?
Yes.
Okay. Because related literature, at between day 11 to day 14, that would have already the proliferation of the blood vessels, and you have the creation already of the capillary plexus.
Yes.
So won't that be a misleading effect in terms of your intervention?
For that, what we were able, there may be formation of the plexus, but this usually will start within the embryo. So at the chorioallantoic membrane portion itself, the vessels will not have yet reached there. We chose these days because one, there's already formation, and we can clearly count and quantify them. And two, the formation are not so developed in such a way that after X number of hours or X number of days of incubation, the blood vessels are not so, there won't be so many that we cannot quantify them. So this was the portion where it was midway from just growing to not yet fully developed.
But I think the limitation there is the quantification of the interaction of the anti-androgenic effect of the intervention with the CAM vessels rather than with the pro-androgenic.
I guess so.
So you cannot actually be sure in terms of those two, which one of those will be.
Yes, that is indeed also one. Thank you.
Okay, choosing the number of days and also choosing between chicken and duck. Difference in the number of days. So thank you, Ms. Alcazar. For the audience, I saw you raise your hand first. Please state your name and your institution before the question.
Yes, good morning. I'm Rogelio from PCHRD. Thank you for your presentation. Actually, I have a comment and a question. My comment applies to all presenters who are doing natural products research, because I haven't noticed anyone getting the GPS coordinates of their sampling sites. Because there's a thing we call ecotype. The soil condition and the microclimate of the sampling site also affects the activity of the plant, the components of the plant, so also affects the activity. So I think we should also get the GPS coordinates. And then, may I ask, how did you dry your macerated samples?
So the mangosteen pericarp was first cut and then air dried for 24 hours, after which we dried them using hot air oven at 65 degrees Celsius for 40 minutes, and then we ground them. So these steps were based on another study that was that checked on which drying and extraction process was best suited for mangosteen.
Yeah, I'm asking about the macerated alcohol.
Oh, I'm sorry. For the alcohol, we took 10 grams of dried powder and extracted with 400 ml 95% ethanol using water bath extraction with constant agitation at 55 degrees Celsius for 2 hours.
So you dried it using water bath?
No, we dried it first and then ground them.
You dried the alcohol extract using a water bath?
No, that was just for extraction, after which we filtered and then concentrated and then, yes, dried.
So you used the alcohol, you didn't dry the alcohol?
No, we didn't.
From the sample?
No, the thing here is, even though we use alcohol to dissolve the pericarp, to dissolve the extract, since upon our studies we found out that the mangosteen extract was only soluble in ethanol, we made sure that the ethanol actually dries very quickly. So before we apply them on the choriolentoic membrane, just 1 to 2 minutes, they were already dry. So the alcohol was still not applied on the choriolentoic membrane.
Okay, so but then you still used oven drying?
I'm sorry?
You still used oven drying?
Yes, yes.
Because my concern is there may be thermolycal components in your samples which may have degraded.
Oh yes, that was in our research that we followed. The research compared 3 different temperatures at 3 different times, and in their recommendation, the best time and the best temperature to oven dry mangosteen was at 55 degrees Celsius for 2 hours, and not more and not less. So not higher temperature at the last time, or longer temperature at longer time at the last temperature. So this was the best time based on the study that we checked.
Thank you. So we only have time for one question, so sorry for that. Thank you, Ms. Atazar.
Thank you, Ms. Atazar. Some reminders for our audience. Kindly accomplish the evaluation sheets that are found in your kits marked parallel session, and that will greatly help the organizing committee. So you can do it now while you still are in the session hall. Also, be reminded that the professional research competition will also be held in this venue from 1 p.m. to 4 p.m. this afternoon. So we go on. Our fourth presenter will share with us the study entitled Determination of the Anti-Angiogenic Activity of White Angel Hollarina Antidysenterica Leaf Extract using Chorioallantoic Membrane Assay. Let's welcome Ms. Reynalyn. Let's welcome Ms. Mara Luella Tangilan.
Cancer has imposed a heavy burden towards the society for a very long time, starting from a simple cellular aberration, followed by the failure of the body's repair mechanisms. This disease can turn a peaceful life into a chaotic one. Several treatments have been tried. Others became successful, while some failed, which led to untimely demise. And now, I present to you a research study which may in the future change the course of cancer treatment. It is the study entitled determination of the anti-androgenic activity of white angel Holleran antidysenterica leaf extract using the choroallantoic membrane assay. According to the World Health Organization, cancer has been named as the leading cause of death worldwide, accounting to 14.1 million cases in 2012. It is a major concern of not only to the public but also to the medical field. Several researches worldwide are continually being established to identify possible treatment for the disease. From the failure of the body's repair mechanisms, solid tumors cannot grow beyond the size of 1 to 2 millimeters. They require delivery of oxygen and removal of waste products. Cancer cells can grow and invade normal tissue through the help of the process called angiogenesis. Angiogenesis is the process of creating new capillary vessels through sprouting from already existing blood vessels in a process involving migration and proliferation of endothelial cells. Endothelial cells are long to be considered as genetically stable than cancerous cells. This genomic stability confers an advantage of directing endothelial cells through anti-angiogenic therapy compared to chemotherapy directed to cancer cells, which rapidly mutate and acquire drug resistance to treatment. For this reason, endothelial cells are thought to be the ideal target for eradicating cancer. The white angel is an ornamental plant which belongs to the family Apocynaceae. The Apocynaceae is the family where Catharanthus roseus and Calotropis procera belong. The Catharanthus roseus is the only commercial source of monoterpenoid indole alkaloids which have anti-cancer activities, the vincristine and vinblastine. On the other hand, Calotropis procera was found to have an anti-androgenic activity mediated by the VEGF pathway. The white angel or Holleran antidysenterica is part of the Ayurvedic medicine as a remedy for various diseases, though its effect on angiogenesis remains unclear. It's also involved in inhibiting inflammation. It contains components such as conicin, conesimine, merconicin, and other indole alkaloids derived from colonine. The plant's abundance, phylogenetics, presence of bioactive components, and lack of local studies are the reasons why the researchers have chosen this plant as the subject of the study. In the study, ibuprofen was used in order to compare the effect of the leaf extracts. Ibuprofen inhibits angiogenesis by inhibiting the VEGF through reducing the hypoxic-induced factor or HIF, which is expressed by cancer cells under hypoxic conditions. In this study, the assay used to test for the anti-androgenic activity of the leaf extract was the choroallantoic membrane assay. Established in 1947 by Judah Folkman, this assay was used in several studies involving angiogenesis. The researchers have chosen this assay because of its high reproducibility, simplicity, and cost-effectiveness. The objective of this study is to determine if the leaf extracts of Holleran antidysenterica can inhibit the formation of new blood vessels using the choroallantoic membrane assay. For this methodology, after crude extraction, the leaf extracts of white angel underwent choroallantoic membrane assay. The protocol used was the one prescribed by West et al., the non-focal sample application technique. 0.3 ml of the sample plus the solvent was applied to the choroallantoic membrane assay using a 1 ml syringe. On day 7, the choroallantoic membranes were gathered during the day 12. Visual assessment and photography followed thereafter. control groups were used: the environmental control group or the untouched eggs, the positive control group or the group administered with ibuprofen and NSS, the negative control or the group administered with ethanol and NSS, and the test group administered with 19.28 microgram per ml Hyaluronate dysentery leaf extract and NSS. The concentration of the sample was based from the 1/10 of the lethal dose concentration prescribed by West et al. Branch point density was computed using the formula number of branch points in the blood vessel segment divided by the length of the blood vessel segment. The length of the blood vessel segment was measured using the image J 1.40 G open access. And statistical comparison was made using one-way ANOVA followed by Shefay test for pairwise comparison. These are the stereoscopic images of the representative fractional segments of the chorial and thalamic membrane per control group. Picture A is in the environmental control or the untouched egg. Picture B is the negative control or the group administered with ethanol and NSS. Test control was administered with the test control, the 19.28 microgram per ml Hyaluronate dysentery leaf extract and NSS, and the picture D is the positive control administered with ibuprofen and NSS. The branch point densities per group were for environmental group is 5.08. For the negative control, the branch point density is 4.47. For the test control, the branch point density is 1.321, while for the positive control, the branch point density was 1.16. So based on statistics, the significant difference between the environmental control and the negative control, the significant difference is 0.662. Between the environmental control and the test control, the significant difference is 0.00. Between the environmental control and the positive control, the significant difference is also 0.00. Between the negative control and the test control, the significant difference is 0.00. Between the negative control and the positive control, the significant difference is also 0.00. While between the test control and the positive control, the significant difference is 0.992. So based on the results, the researchers concluded that the Hyaluronate dysentery leaf extract significantly inhibited the development of capillary networks in the chorial and thalamic membrane. And for further studies, the researchers would like to recommend first to identify the exact phytochemical components of the Hyaluronate dysentery leaf extract that are responsible for its angiosuppressive property and determine their possible mechanisms of action. Lastly, to determine the extent of effect of the Hyaluronate dysentery leaf extracts by establishing the concentration gradients. That is all. Thank you.
Well, thank you, Stabila. Whose turn is it? Ask this question. Rodriguez?
In your paper, you use leaves,
Yes.
but in related literature, almost always they use the bark.
Yes, because from previous studies, the bark of this plant, Hyaluronate dysentery plant, is very extensively studied. So we chose these leaves as a preliminary study or pioneer study.
Has there been a previous study using leaves? Because all the literature that I've looked at used the bark, and I didn't see leaves. Has there been any previous studies? In your, we were limited in terms of looking for literature, related literature. Perhaps you encountered because you had a longer time to do it?
I have encountered studies about the leaves regarding the phytochemical constituents of the leaves, but not for the anti-androgenic activity. That's why we started this research.
And you only looked at one outcome in terms of the blood vessel, that is branch point number.
Branch point density.
That's different from the branch point number.
Branch point density is number of branch point density divided by the length of the blood vessel segment. So we manually counted for the branch point per blood vessel segment. Then we divided the number of branch points per.
But the point I'm getting at would be in most studies researching on the anti-androgenic effect. For example, for this particular paper, this is perhaps the first time you're using leaves, would look at other outcomes like the number of blood vessels, the diameter of the blood vessels, the permeability, the blood flow, etc., aside from the density.
Maybe for future studies, we can recommend.
Because in terms of the density, that is probably one of the limitations in using the CAM, right?
Yes.
Okay. So looking at other factors aside from that, so Dr. Kuban, the other study on androgenic activity used an anti-cancer drug. You used ibuprofen, so I just want to know why the use of ibuprofen, because of the property, or psychodynamic.
The procurement of the bevacizumab is very hard and it is very expensive.
Yeah, I know. Kaya din, siguro one of the limitations why they have only few subjects, because that drug is really very expensive. In your case, why did you use ibuprofen? Is there some similarity, or you don't know? Can you just expound or explain to us the nationality for this?
Conducted by Goldman said that right now NSAIDs are now used as oral therapy to prevent androgenesis. So since the procurement of the bevacizumab and cost is very expensive, we chose the next best drug that we can use with anti-androgenic activity, but it is available.
Okay. Dr. Arcada?
Thank you. Well, again, congratulations, St. Other Group. And I proceed with the process. One of the areas in field of research is in the data collection. I looked at a lot of references, and then how did you, in terms of process, get this different information that will facilitate and to be utilized for your study, I suppose, the data collection part for the references. Now I'm looking at the process. The second, because I'm looking at the effectiveness of the different types of cancer, are you also looking at in terms of the activity of what are the androgenic activity of the different types of cancers, and then relate it to the finding of your result? So we can have a match of what the white angel can treat in terms of cancer. Is it far already, or are you looking at it in the future? Because maybe we can have this white angel anti-androgenic effect to a specific type of cancer. And this is a very good initial step, because you were able to demonstrate that it has an anti-androgenic activity. But maybe the next step will also look at what specific type of cancer does the white angel can make in terms of treatment for cancer.
Thank you for that question. For the first question, for the data collection, so we chose data or literature that can show us or we can use in order to step by step arrive with that hypothesis or with that conclusion that the endothelial cells are now the ideal target for treating cancer. Then what are the possible treatment that can target these endothelial cells? So there. For the second question, for the what type of cancer, so unfortunately, our study is limited only to the capacity of cancer cells that to express VEGF and switch the androgenic switch towards the pro-androgenic factors, but we did not have time, or it's one of our limitations.
Okay. Question from the audience. No takers? Okay. So thank you.
Thank you, Ms. Sangilan, and she's from Angeles University Foundation. The fifth presenter will share to us the topic entitled "Not All Tawa-tawas Are Alike: Morphological, Molecular, Genetic, Phytochemical, and Anti-Thrombocytopenic Profiling of Different Euphorbia hirta Plants from the Philippines." Let's welcome Ms. Sharia Plain De Paz of UP Manila College of Medicine.
With the continuous existence of dengue fever as a national epidemic, research on natural products related to its management has indeed become an increasing need. Ladies and gentlemen, good morning. Let me present to you our study entitled "Not All Tawa-tawas Are Alike: A Morphological, Molecular Genetic, Phytochemical, and Anti-Thrombocytopenic Profiling of Different Euphorbia hirta Plants from the Philippines." Dengue is indeed a health threat, remaining as a national epidemic that is one of the top 50 causes of death and affecting more than 100,000 individuals in less than a year. With a case fatality rate of 0.81%, we can expect 8 patients to die for every 1,000 individuals affected by dengue. This is caused by dengue virus, serotypes 1 to 4, and transmitted by the bite of Aedes mosquito. The 3 dengue virus-associated diseases are dengue fever, and the more severe types, dengue hemorrhagic fever and dengue shock syndrome. These are associated with symptoms of high fever, rashes, fatigue, joint aches, nausea, and vomiting. Severe phenotypes can present with hemorrhage, hypotension, and eventually shock. Up to the present, dengue therapy has continued to face issues. For one, vaccine is not yet widely available, and current disease management is still highly based on symptomatic intervention. Moreover, when symptoms of severe thrombocytopenia occur, patients face the need of having blood transfusions. With all these complications, herbal interventions has been gaining popularity in the local communities with reports of beneficial effects from tawa-tawa decoction, papaya leaf extract, kamote tops, and the like. Moreover, there are already commercial products like tea and health drinks being marketed nowadays, even if there are still inadequate safety studies of them. The figure that you see at the bottom, these are some of the things or some of the products that we saw in Cubao already being sold in the supermarket. The most popular of all the natural products is tawa-tawa, commonly known in the Visayas as gatas-gatas. Previous studies have shown that it has platelet-promoting activity on thrombocytopenic rat models and in Sprague-Dawley rats. However, there are still no published scientific studies related to its toxicity and characterization of the different tawa-tawa varieties and their respective bioactivities. Hence, communities can actually be misled that tawa-tawa collected anywhere are equally beneficial against dengue. Hence, this study aimed to characterize tawa-tawa samples from different areas in the Philippines using the following parameters: morphologic, molecular genetic, phytochemical, and antithrombocytopenic profile or activity. Why is this study important? The results of this study can actually provide clarification to the different communities and health practitioners regarding tawa therapeutic issues. So it can also provide guidance to concerned parties on identification of suitable tawa-tawa varieties that can be propagated in communities. Finally, it can provide baseline information for future studies and policies on tawa-tawa. This is the general methodology that we use. Of course, first thing that we did was sample collection. So this figure shows us the different collection sites where we got our samples. After which, we did morphologic characterization and cluster analysis. For molecular genetic profiling, we performed amplification, sequencing, and cluster analysis of the RBCL gene. The samples were also subjected to high-performance liquid chromatography, and cluster analysis was also done on the profiles. Finally, we performed in vivo antithrombocytopenic assay in mice. This picture shows the details of the morphologic analysis. We did morphological characterization using those characters and scored each of them using their character traits. So we did cluster analysis using Mega software in order to generate a phylogenetic tree that can cluster samples that are more alike compared to the rest. This figure shows the tree generated upon cluster analysis. Observe that there are two major clades formed, namely clade 1 and clade 2, with strong bootstrap support of 100. Upon submission to a botanist for voucher identification, we later on realized that this clustering was based on species. As you will notice, clade 1 represents those that belong to E. hirta species, while clade 2 belongs to E. prostata species. Hence, tawa-tawa, which, let's remember that when we say tawa-tawa, it's a language of the community, it's not a scientific name. So when you say tawa-tawa, it may not necessarily be Euphorbia hirta, but some other species under the same genus. Therefore, other people can mistake tawa-tawa for some other species. In order to confirm our results further, we did molecular genetic analysis of the plant sample. So we did DNA extraction of the leaves and amplified the RBCL gene using polymerase chain reaction. The DNA amplicons were then sent to Macrogen, South Korea for sequencing. When we got our sequences, we used them as character traits to construct a phylogenetic tree based on the RBCL gene sequences. Consistent with our results, in morphologic analysis, two major clades again were formed, each clade representing one species of Euphorbia. The first clade being the E. hirta clade and the second one being the E. lashocarpa clade. In order to confirm the reliability of our sequences, we also included voucher sequences from the GenBank to our phylogenetic reconstruction. As you can see, these vouchers also clustered accordingly to the samples of the same species, further strengthening our results. This is just the same cladogram I showed you earlier in morphologic analysis, and this is just to emphasize that there was consistency in clustering in samples in both morphologic and genetic characterization, with two major clades formed, each representing a distinct Euphorbia species. The next thing that we looked into were the HPLC profiles of the different samples. We wanted to find out if HPLC profiles from the different samples would also cluster according to species like the previous results. So we first did methanolic extraction of the samples, then run them under high-performance liquid chromatography to obtain the profiles of their active compounds. We did another cluster analysis using retention time of the peaks as character traits, and we finally generated another tree based on the HPLC profile. So this figure shows that the production of gallic acid and catechins are very much varied among the different samples. Some contain both, some just one, some contain high amounts, some contain low amounts. Interesting to note is the commercial drink that contains both active compounds in almost similar concentrations. So this picture just shows you the HPLC profiles of the different extracts. We also included the commercially available drink and the tea being sold in the market in order to see how much they are alike to fresh extracts. So if you look at the profiles grossly, we can see that there is wide variation among the different samples. Important to note are peaks labeled 1 and 2, because Wang et al. Have previously identified 2 active compounds commonly found in plant extracts. So this study by Wang et al. Actually developed a certain protocol for HPLC wherein gallic acid and catechins can be seen. And we use their retention times since we cannot perform highly technical stuff like infrared spectrometry to really identify the actual identity of these peaks. What we did was we used the retention time to just grossly estimate catechins and gallic acid. So based on the neighbor joining analysis, there, 4 clusters are recognizable. So first is cluster 1 in the yellow box, is drink and PGRS. Cluster 2 in the red box, PGRB and LBG. Cluster 3, TGB and CG, and cluster 4, T and QCG. These letters that you see are just codes, and they would signify the location from where these plant specimens come from. Note that PGRS is shown to be a different strain from E. hirta, and this clusters with a drink. This means that the drink could be using the incorrect tawa-tawa, or is probably synthetic, because there is no other peak observed in the HPLC profile but catechin and gallic acid only. So if you observe, PGRS, if you recall it earlier, was identified as E. lashocarpa. However, we see here that the drink, the commercial drink being sold as tawa-tawa, actually clustered more with the Euphorbia species that is not E. hirta. Also, please note that clusters 2 and 3 are 2 hirta species based on previous morphological and RBCL sequence analysis. Also note that T, clusters with QCG, thus the commercial tea preparation, is indeed from E. hirta. It is also important to note how the E. hirta species scattered among the different clusters and how the clades containing PGRS and PGRB further clustered together even if they belong to different species. Both of these samples, however, PGRS and PGRB, come from the same location site, which is Pagagian. This may further imply that environmental factors may play an important role in the production of active compounds that might just be relevant in tawa-tawa. These cases are actually not unheard of. For example, when you talk about ampalaya extract having anti-diabetic activity, only those collected from Mount Makiling show these results. So actually there can be variation, and these activities may actually depend upon where you get them. Okay? So the last thing we did was antithrombocytopenic activity assay. So we used 3 groups, 1 control and 2 treatment groups using LBG and QCG extracts. We did blood extraction and platelet counting to establish the baseline. And then we treated all the mice with cyclophosphamide for 3 consecutive days to induce platelet reduction. We then treated the animal models with tawa-tawa extract for succeeding 12 days. We performed subvenous vein extraction from the 3rd, 6th, 9th, and 12th days post-extraction. Platelet counts were obtained through hemocytometry, and after doing all measures, we terminated the experiment. So this figure shows the results of the antithrombocytopenic assay. Most important to note is only QCG and not LBG induced a significant increase in total platelet count after 12 days of tawa-tawa treatment relative to control. Moreover, we can see here that although both extracts showed seemingly immediate antithrombocytopenic effects, the pattern of its antithrombocytopenia varies with time. LBG showed fluctuating mean platelet counts, while QCG formed a more stable platelet count, declining only in day 12. This may also be correlated with survival rates of the mice. The control group, which showed the least platelet count, had the highest number of deaths, followed by the LBG treatment group that showed fluctuating patterns of platelet count increase. The group with the least percentage of deaths is QCG, the treatment group with a significant regain in platelet count and a relatively stable pattern of increase. It showed mortality on the 12th day already. Another interesting thing to note here is that although the QCG extract can rapidly restore platelet counts as early as day 3, mortality was still seen in day 12. This may imply that although it has antithrombocytopenic activity, accumulated dosage of the treatment may lead to death or toxicity. So hence, from our results, we present the following conclusions. First, there are 2 plates of putative tawa-tawa in a typical field collection area where these plants grow, the Ihirta clade and the Elashocarpa or Prostata clade. A morphological characterization scheme was determined and validated by RBCL sequence analysis, thus would help in correct field identification of tawa-tawa. Second, the HPLC analysis of the phytochemical signatures of these plants revealed that tawa-tawa samples of the same species do not necessarily produce the same relevant compounds. Commercial products of tawa-tawa can be mislabeled or adulterated with non-Ihirta species. Third, the antithrombocytopenic activity of tawa-tawa extracts could vary in terms of pattern with corresponding effects on survival. QCG proved to be better than LVG with more stable antithrombocytopenic activity. Last, prolonged intake of tawa-tawa more than 6 days should be discouraged as it should have toxic principle that is responsible for the mice mortalities in the in vivo animal assay. Hence, we recommend that caution must be taken when promoting the health benefits of tawa-tawa or gatas-gatas, in that not all tawa-tawa produce the same compounds, even though they appear to be morphologically similar. Moreover, further studies must be done to confirm the toxicity of the extract. And finally, antiviral activities of the extract may also be explored to elucidate claims on its therapeutic effects. So thank you very much for your attention. Good morning.
Thank you, Mr. Bass. Observe an animated discussion between our 2 judges here. Let's start with Dr. Potenta.
Thank you. Again, congratulations to your team. I would like to look at again the first process of your conduct of the research. I would like to look at because I look at your references. How did you acquire the data that will be utilized for study? I'm just wondering because there's a UST study on which PCHRD actively supported. It's not part of the reference. It's a very good reference material. Secondly, we've been discussing this even in the Department of Health and some private sector in terms of if we will, if the Department of Health can include this as part of the medicinal plans. And how do you see with your findings of your study that this could be included? And are you comfortable with saying at this point you can say this has a very good effect in terms of for the implication? Are you comfortable with saying that?
Okay, so for the first question, ma'am, what we did was we scanned literature, but we only included those that were actually cited in the paper. So there are limited studies with regards to tawa-tawa, and so yes, with regards to the USD study, I don't think I've encountered that yet. So for the second question.
Are you comfortable with
From our results, ma'am, I would not be confident to recommend it yet. First is, there is still very insufficient data when it comes to its toxicity. So what actually bothered us a lot were the mortalities in the mice. So we wanted to, it's a very preliminary study, the mice study. So we want actually to proceed into doing actual toxicity studies on this. We actually tried to do cell culture using hepatocytes to also see if it can be toxic against liver cells. However, we failed for that part and we were not able to proceed with that since there was no longer time. But that's really one thing that we want to look into. And secondly, I wouldn't recommend that yet as of now, since it would be better if there would be better sample collection from really different areas from the Philippines and not just limited to the 10 sites that we have. So since this is just a preliminary study, I think it would be much better to really jumpstart an actual, broader study that can really go into the different effects or varieties of this plant.
Okay.
Another study actually, the St. Luke's group also studied the tawa-tawa.
Yes, ma'am.
And I think that also as one of the reference materials.
Yes, ma'am. St. Luke's actually is my friend, the one who's doing it. that study. He's looking into antiviral activities of tawa-tawa. But I don't think this is already published. This is a new study, and I just heard about this in a conference. So yeah, we did not include that since what we were actually interested about was the platelet promoting activity, since that was the published study.
Okay, thank you. So let's just put the brakes first on drinking tawa tea before further positive studies. Dr. Hubay?
Okay. Thank you for telling us that there are levels of tawa-tawa. You may sound that walang sound and then. Okay. Okay. Yeah, may sound ka. Okay. Now, if by chance we give you the power as an FDA, what would you do as a policy with the result that you have?
If I were if I were given the power for the FDA, I would really, because it's very common, sir, in our country. You know, we just when we find that this extract has this activity, we easily go into putting it in the market. So I would really suggest, and then we say in TV that there are no therapeutic claims. So there can actually be a lot of errors in relation to this, because some may actually think that this works, or some may not know that it's toxic or something. One of the weaknesses of natural products is we don't know what's there. Most of the time we use fruit extracts. Yes, we know it has this effect, but what else is there? So it's very, very important to really go into toxicity studies before allowing these teas or natural products. So if I were the FDA president or whatever, I would executive director. I would like to demand sufficient data first to prove that it's safe and it's actually effective before we're going to release it out to the public. If that would be possible, sir, why not?
Also, congratulations for this paper. It's quite a significant paper. But what was actually the basis for the geographical sites that you chose?
Actually, sir,
because you put forward is it a theory that I didn't see any evidence that environmental factors may affect the active compounds?
Yes, sir. It's more of a hypothesis, sir, than a conclusion. So this is actually more of purposive. Since we are students and we really can't, travel all around the Philippines. We had teammates who went to certain places and traveled there. So whenever they did, we requested them, will you please, since you're going to this place, can you please get tawa-tawa for us? So yeah, some of our teammates did that. I'm from the province myself. So we just collected based on our ability to go. So yeah.
In the first place, what made you think that not all tawa-tawas are the same?
So first, sir, it's very common, sir, actually.
Because that would probably be the basis for your geographical sites.
I'm sorry, sir?
That would probably be the basis.
Yeah.
Your
Yes, sir. Look into just language first. Tawa-tawa versus euphorbia hirta. It's very easy to make a mistake, sir, that you will think it's tawa-tawa. So that's the first level of argument, that not all tawa-tawas are alike, because probably it's not euphorbia hirta. Second is there could be varieties in terms of location. And third is if you actually observe the results, the botanist identified the other species as Euphorbia prostata. But when we did genetic analysis, the hit was not Euphorbia prostata, but Euphorbia lashocarpa. So that's actually another issue if you're going to go into plant taxonomy, how do you really label species based on genetics or morphology? So there's, yeah, so not all tawa-tawas are really.
So the morphology would also indicate that they would have different levels of the active compounds.
Yes, sir.
Or the platelet promoting activity.
Yes, sir.
Then my next question is, why did you only investigate on 2 samples from 2 sites in the
anti-thrombocytic? Yes, sir. That's a very interesting question, sir, because we would have loved to really examine all the samples that we had. So we had 10, and we wanted to look into that. Unfortunately, with all honesty, this experiment came last, and we only conceptualized to proceed into this after getting the results of the previous experiments. And we don't have enough samples anymore for the assay. So what we had was from Quezon City and Los Baños, because that was the easily accessed. We cannot go back to Mindanao anymore because no one was traveling there. So the nice thing about Quezon City and Los Baños is it represented urban and rural. And that's the only 2 sites where we had enough samples to proceed into the mouse assay. But had we have enough samples to do everything for the mouse assay, it could have been better, sir.
Yes, because I was interested in the clinical application of the research. And this is quite significant because, there have been toxicity studies done. That's why that's the basis already of clinical studies that are being done in humans. And probably this would be, should be taken into consideration because you actually bump into a result where you can prove that not all tawa-tawas are the same. And therefore, the active components may actually not be the same also. So depending on the toxicity studies that have been done and the animal and human studies that have been done, then they should take into consideration the results of this study. Perhaps the gap of doing all the samples from the different sites should be done in future studies so that we can determine the platelet promoting activities of the different tawa-tawas.
Yes, sir. If I would have to present another research proposal right now, I would really love to go into antiviral activities of tawa-tawas from different areas of the Philippines as well.
I think the previous studies have already confirmed that there are no antiviral activity of tawa-tawas. It's only in platelet promoting. There are other plants, however, herbs that would have antiviral. And so the future of research in this field of anti-dengue drugs would include combinations of these plants together with tawa-tawa.
Yes, sir.
One having anti-platelet, platelet promoting, and the other one having antiviral.
Thank you. We have time for one quick question from the audience.
Good morning. Thank you very much for your sharing. I'm very happy that, at least for now, this has been an open thing. For the past 5 or 6 years, I came across an investigator, a German investigator, who said that tawa-tawa, well, we have another name, Mangagaw. That probably tells you that there are so many species. So we have tawa-tawa, we have kapas-kapas, and we have Mangagaw. Here in Cebu, a lot of them call it Mangagaw. So I'm happy this is open because that German investigator said, UP people says it's not effective for dengue. Why? Because the Visayan version are the only ones effective. I thought the Visayan Mangagaw are the ones that's effective. I thought, well, maybe later you can ask me. I will be very happy to supply you with Mangagaw from Cebu. So if you want to study that, we don't have the resources that you have in UP or in Manila. So thank you very much for opening this venue.
Thank you very much.
I can see from the audience that you have questions you want to ask, but we really don't have time. Please just write your questions on a piece of paper and I'll forward it to the presenters, and maybe you can have the discussion later during lunch. Okay. So, a big hand to the presenter. Okay.
Thank you very much.
Thank you, Sharia. Just a reminder, your evaluation sheets will be collected by our ushers and usherettes. Now we go to the last presenter, and the title of the study is Anti-Developmental Effects of Callistemon viminalis, Whipping Bottle Brush, Leaf Extract on the Early Development of Trypnustis gratila embryos. Is represented by Geraldine Cercado of Cebu Institute of Medicine.
Just say next if you're ready for the next slide. Just say next if you're ready for the next slide.
Good morning, everyone. Again, I am Geraldine Cercado from Cebu Institute of Medicine, and I'm here to present our research entitled Anti-Developmental Effects of Callistemon viminalis Weeping Bottle Brush Leaf Extract on the Early Development of Trypnustis gratila Sea Urchin Embryos. Cancer is a leading cause of mortality and morbidity in the world. In 2012, 14.1 million were diagnosed with cancer, and 8.2 million cancer deaths were estimated worldwide. And one of the most widely used or practiced clinical management for cancer is chemotherapy, which is expensive and hard to avail. This has led to great advancements in the study of naturopathic medicine. These include studies on Callistemon species native in Australia, which have been proven to possess cytotoxic effects. Callistemon viminalis, widely distributed in the Philippines, and is a shrub to small tree with aromatic and lanceolate leaves and bright red flower spikes as shown in the figure, may also hold such promise. Further, this species has no documented anti-developmental effect on sea urchin embryos. Sea urchin embryos have long been used as models for anti-cancer drug testing. This is for several reasons, and most importantly because sea urchins share similarities with the human genome. Hence, in this study, we investigated the anti-developmental effect of Callistemon viminalis on sea urchin embryos. So the general objective of this study is to determine if Callistemon viminalis leaf extract exhibits anti-developmental effects on the early development of Trypnustis gratila embryos using seawater as control. Specifically, we aim to determine and compare the proportion of embryos present in each of the developmental stage and the proportion of embryos having morphological aberrations exposed to seawater and in the different leaf extract concentrations. Secondly, we aim to determine the proportion of embryos that has reached blastula stage 24 hours post-fertilization, exposed to different leaf extract concentrations and seawater. So in vitro controlled experimental research design was employed in this study. And we conducted the study in the University of San Carlos, Maribago Marine Station, Cebu. And in a brief explanation, our methodology included application of the leaf extract of this plant to the fertilized eggs of sea urchins and monitoring of the embryologic development for 24 hours. So first, we prepared the leaf extract of the Silliman viminalis. So the leaves were collected from Talambal, Cebu City, and only fresh mature leaves of the plant were used. The leaves were washed with distilled water, air-dried, cut into small pieces, and soaked in ethanol for 48 hours. The mixture was then filtered and then concentrated using a rotary evaporator until a dark green syrupy pure leaf extract was obtained, as seen in the figure. Next is the preparation of the sea urchin embryo suspension. So the collected male and female sea urchins were induced to undergo spawning through injection of the potassium chloride in the coelomic cavities of the sea urchin. And afterwards, each of the sea urchins were placed in the brim of the beaker to collect for the secretion. And the male and female gametes were distinguished by the color or the characteristic of the secretion. So the white yellowish emission contains the male gametes, while the orange granular secretion contains the female gametes. And then they were collected in two separate beakers, and then we diluted them. And the embryo suspension is prepared by mixing the male and female gametes with a ratio of 140 ml male gametes plus 350 ml female gametes. And this mixture was left for 30 minutes to allow fertilization. So these are the photos of our actual experiment. After which treatment solutions were prepared. So we have 7 treatments. First is the 100% filtered, sterilized seawater as the control. And then for the experimental group, we prepare different concentrations of Silliman viminalis leaf extract, namely 5%, 10%, 25%, 50%, 100%, and 100% concentration weight per volume. For the application, each treatment had 5 replicates, each containing 40 ml of the treatment solution, added with 10 ml embryo suspension, and only one trial was done for this experiment. Next is the monitoring and evaluation. So 1 ml aliquots from each replicate containing the embryos were observed with the use of a microscope, and we monitored for the following time intervals. So every 30 minutes for first 4 hours, and then every 2 hours for the next 20 hours. Therefore, we have a total of 24 hours monitoring. And then for every time interval, we counted the following. The number of embryos undergoing the following stages: 1 cell stage, 2 cell stage, 4 cell stage, 8 cell stage, 32 cell stage, morula, and blastula. And here is a figure showing how these cells look like. So you have an idea of how the embryos you are counting look like. So here, 1 cell, 2 cell, 4, 8, 16, 32, morula, and blastula. And also, we counted for the number of embryos with morphological abnormalities. Next is the anti-developmental activity evaluation. So we computed for the percent composition or the proportion of embryos. So this is calculated through the following formula. So number of embryo in a specific cell stage, or the number of embryos with a specific type of abnormality, divided by total number of embryos times 100. So here are the results of our study. So this shows the embryologic development over 24 hours exposed in seawater. And remember that seawater is our control. So to orient you first with our graph, the x-axis is the time after fertilization. This is in hours. And the y-axis is the proportion of embryos. So that's in percent. And each color denotes a specific cell stage. So for example, the blue one is one cell stage. And seawater, as again I mentioned, was used as control to observe for the normal development of the embryos. Hence, this graph shows the normal development, in which evidently there was transition from one cell to the next cell. So to explain further, look at the cell population in half hour after fertilization. So the cell population is composed mainly of one cell stage and two cell stage. And after another half hour, so that's 1 hour post-fertilization, there is appearance of the 4 cell stage. And then for the next half hour, another cell stage. So this development was observed until the 4th hour here, during which the population was composed of morula and the blastula. And from the 4th hour till the 24th hour, the dominant cell stage is the blastula. Hence, in this study, after 24 hours monitoring, the farthest stage reached by the embryo is the blastula stage. Moreover, important to note in this graph is that there are no abnormal cells. All are normal cells. So this next graph shows the embryologic development over 24 hours, 5% leaf extract concentration. So as observed, there is embryologic development. However, the rate was delayed as compared to that in seawater. So to point out, the 4 cell stage appeared at 1.5 hour post-fertilization, while as you can remember, I have mentioned that in seawater, it's 1 hour post-fertilization. And as you can see in the graph, there was an evident difference from that in seawater. So look at the graph towards the end of the experiment, specifically starting from the 8th hour to 24th hour. So these colors were not observed in seawater, and these were the abnormal embryos, namely the arrested cell, burst cell, atypical cell, and deformed cell. Later, I will define these abnormal cells and show you how they look. So in short, 2 important observations here that differ from that in seawater were the first, delayed in development, and second, the presence of abnormal cells. So this shows the embryologic development over 24 hours at 10% leaf extract concentration. So as you can see in the graph, the predominant cell stage is the 1 cell stage. One cell stage, and that no embryo or no cell stage beyond 1 cell was observed, indicating that there was no development. And also there were abnormal cells. So for the rest of the leaf extract concentrations higher than 10%, namely 25, 50, 100%, the same results as that in 10% was observed. That is, there was no development and there were abnormal cells. So this figure shows the normal development again, and then this table shows the time of development in R, comparing seawater and 5%. Since there was no development in 10% and higher concentrations, so the comparison was done only between seawater and 5%. And as you can see the time, for example, in 2 cell, in seawater, the embryos reach 2 cell at 0.5 to 1 hour post-fertilization, while in 5%, 1 hour to 1.5 hours, and so on. So this is to further emphasize that there was delayed development in 5% concentration of the leaf extract. So this graph shows the percentage of embryos reaching blastula stage 24 hours post-fertilization. So here in seawater, after 24 hours, 99.4% of the total number of embryos reached the blastula stage and 0.6% were in morula stage. While in 5%, 10%, 25, 50, 75, and 100 leaf extract, there were no embryos that reached blastula stage. So this signifies that the leaf extract at different concentrations exhibited inhibition of the normal development of embryos. So here are the morphological abnormalities we observed in our study. So letter A is the atypical cell. So we define atypical cell as one cell stage embryo that has undergone an uneven cell division, producing two unequal in size daughter cells characterized by budding off of a smaller cell from the main cell, and there is an intact cell membrane. Second is the deformed cell, a cell with swelling of protoplasmic material or protrusions with no signs of membrane discontinuity. And then letter C is the burst cell. So this is a cell with ruptured cell membrane and extrusion of cell contents. And letter D is the arrested cell, the cell that failed to develop from one cell stage. Next slide, please. So in conclusion, the leaf extract of Callistemon viminalis exhibit anti-developmental effects on the sea urchin embryos, specifically developmental delay, cell arrest, presence of deformities, burst, and atypical cells. Second, 99.6% of embryos in seawater, while none of the embryos in the different extract concentrations reach blastula stage 24 hours post-fertilization. Next slide, please. So we recommend the following: the isolation and characterization of the specific bioactive compounds responsible for the anti-developmental effects of the leaf of Callistemon viminalis. Second is to test the other parts of Callistemon viminalis, so maybe the roots, the stem, the bark, the flower, for similar anti-developmental properties, and also possibly to test on various cancer cell lines. That's all. Thank you.
Thank you very much. Now let's start with Dr. Looking at you, Dr. Frias.
You looked at two outcome measures. One is developmental delay, and then the morphological characteristics of the cell. What is the difference between the delay in cell development and the arrested cell?
So the delay in development, first is that there is presence of development, so therefore there is transition from a cell stage to another, while in cell arrest, we operationally define it as a cell staying at one cell stage, and that there was
one cell.
Yes, one cell stage and no further development.
Because in your data, in terms of the morphological differences or aberrations,
yes.
in the 10% concentration, you have burst cell and arrested cell, whereas in the 25% concentration, you had only arrested cell. In the 100% concentration, you again have arrested cell and burst cell. If your main outcome measure is arrested cell, because that would not progress to further development, why did you not continue on looking at the different concentration instead of just stopping at the 10% concentration? In the morphological aberrations that you investigated, in the different concentrations, the 25% concentration only showed arrested cell. There were no other morphological aberrations noted. Whereas in the 10% where you actually stop in determining the cell development in your data, considered only up to the 10%.
Yes.
But in the 25%, had sila arrested cell. Pagdating mo dun sa 100%, may mga iba pang morphological aberrations. So why did you stop at 10% concentration instead of investigating all the other concentrations to determine whether the 25% would have been better or the 100% would have been better or less?
So actually, in our method, for each concentration, each extra concentration, we observe for all the morphological aberrations. So like in 10%, we observe for the arrested cell, burst cell, and all the kinds of cells, and also in 25. So the observations there were the only observations we observed.
But there were no data presented on the 25% up in terms of cell development. Because as you can see in the 10% concentration, the development also included some morphological aberration instead of just arrested cell.
And so yes, in our paper we.
But in the 25%, your data shows that all of the cells were on arrested stage. One cell.
Okay, so I think it's not in our paper. Actually, we have graphs for all. We have results for all the concentrations, but we didn't.
No, we didn't have that.
Yes.
So you did.
So
you did
for
your report, but you have.
But in
those
your
results.
in the manuscript, you said you stopped at 10%.
no, we didn't stop.
So it would have been better to also see the results based on that.
So
Other
yes, in our previous papers, since we revised that many times, we chose since we observed that in 10, 25, 50, and 175, the results are more or less the same. So we chose not to present the 25, 50, and above. But in our previous version of our manuscript, we included the pattern or the embryologic development for 24 hours for all the concentrations.
Because in terms of clinical application, that would have been a significant data to consider.
Yes. Thank you, John.
Okay. Dr.
Okay, congratulations to you and your team. First, again, the process. How did you develop your conceptual framework and help you on practicality? I'm just wondering because medyo mahirap yung study. To have the origins as well as, use that as your sort of medium for your study. Medyo mahirap yun. And did you consider other methodology that could probably give you result, but in terms of but in terms of how did you do the methodology? Will give you things result but faster and easier, meaning the resources are lesser. Which I can say this is a very expensive study. Not really? Okay, not really. But to me, it's difficult study. But I again appreciate in terms of pursuing, because of, to me, this could probably in the future that will help us in terms of how do we support managing cancer.
So
The anti-development effect of this of the yung weeping, sabi ko, patuloy ako, weeping. Yung si Orchie, nakakatusok. Lahat negative, weeping ka na. Diba? Parang gano'n. But anyway, so but how did you go about it? Because I think how did you make this research, the choice of making this research and developing that conceptual framework? My second in terms of how do you proceed from here? So we can continue, so you can continue to pursue your study. And sa akin, baka later, this will be a good in terms of policy for that. And will give us an impact in supporting productive units.
So I would just like to inform that sea urchins is not really that difficult to utilize because there are several studies utilizing sea urchins for anti-proliferative, anti-mitotic, anti-developmental activity, and in the Philippines, there are abundant supply of sea urchins, and it's easily accessible, and it's the production of sea urchin is not expensive, and the fertilization process is so easy. As I have shown you in my report, the induction process is you only need to have potassium chloride, and moreover, the sea urchins will not die in this process, so you can return it to their natural habitat and recollect them for future. So it's not really that difficult to utilize sea urchins. And actually, during our college days, in our physiology exercise, we used sea urchins. So it's not that difficult to use. This study is easily replicable for future, for anti-developmental or anti-mitotic studies for other plants. And in terms of Callistemon viminalis, yes, maybe it's not familiar to all of you, but we come up with this plant first because as we searched in the internet, we came across Callistemon citrinus, Callistemon lanceolatus. So these are species native to Australia, and these species were extensively studied in terms of different activities. So namely anti-proliferative, antioxidant, antimicrobial, antifungal. So we thought that is there any species, Callistemon species in the Philippines? And we came across Callistemon viminalis, and there is no study about its anti-developmental effect. And it happened that this plant is present in my school, so it's easily accessible. Yes, the availability.
Okay. Let's go to Dr. Rupan.
Sarap yung si Erkin. Hopefully, the one I ate last night didn't come from your study. Ask FMB of the hotel. And the arrested probably ano yung piyansahan nila kaya ganun. Kaya nawala na. So, now, I'm just looking at it, that at least in one viminalis, sabi mo, wala pang local studies except for this one. This is asking like, in other settings, they're looking at it in other uses, antimicrobial. Kailan na, puro lang kasi yung narinig natin for this morning, most of the studies are for anti-cancer. And probably you can highlight some other uses of this plant products. Kala ko nga sa reproductive health ang gagamitin to kasi may arrested development. Sabi ko, patay, ito tayo. So I'm just looking at it. Just explore for probably recommend other uses in terms of or other ways of looking at how we can use this clinically aside from cancer.
Thank you.
Thank you. One question for the audience, because it's almost 12, and I've just been informed that it's ready outside. So, sir, you may ask a question.
Erwin Silliman from the Darlang State University. Thank you for your very good presentation. I just want to give emphasis. Have you explored on your literature the ethnobotanical principles of your plant? Because in our place, particularly in our capital grounds, we have that particular weeping tree. Because our governor is very fascinated with that flowers para sa mga lumber. So have you established the ethnobotanical principle of that plant?
Actually, we've searched about this plant in our locality, and what we have found is that it is only widely cultivated in Baguio. And actually, we also searched for the local name and it has no local name. So the distribution of this plant in our locality is not yet studied. Yes. And it's not even in Flora of Manila. So a book about the plants. So
So must. Okay, so that is it. We've heard 6 presentations. For last words or reminders, may I give you back Dr. Robert? Let's give a big hand to our last presenter.
Thank you, Geraldine. May we request those who just presented to please stand up and be recognized. Those from presenter number 1 up to 6, can you please stand up? Let's give them a round of applause for sharing with us the work that they have done in their research units. At this point, I'd like to call on Dr. Debbie Abdul to proceed with the awarding of certificates.
PNHRS, Philippine National Health Research System, presents this certificate of appreciation to our honorable judges. And the citation states that in recognition of her invaluable contribution as judge in the oral research presentation as student category, given this 12th day of August 2014 during the 8th PNHRS Week celebration at Radisson Hotel, Cebu City. Signed, Jaime C. Montoya, MD, Lead Coordinator, Philippine National Health Research System, Enrico B. Gruet, MD, Chair, Central Visayas Consortium for Health Research and Development. May I now call Dr. Maria Ofelia Ocania Alcantara. Dr. Melchor Frias IV.
And Dr. Noel Uban.
For the presenters, we have Leslie Jane Vasquez,
Janelle Poblete. Janelle Poblete. Nora Luella Sangilan. Miss Elizabeth Grace Alcazar. Sharia Lane De Paz